question says, for the following, identify the properties of the operations for whole numbers illustrated. Now, when we look at 7 plus 0 equals 7 equals 0 plus 7, that is the identity property for addition. B, m plus 3, that quantity times A, is equal to m times A plus 3 times A. That, even though we usually see the A on the other side of the m plus 3, this is the distributive property. And if you really wanted to get technical, it'd be the distributive property multiplication over addition. But distributive property is just great. Number C, 5 times the quantity 20 times m is equal to the quantity 5 times 20 times m. If you see, what we're doing is the order of the numbers has not changed, and it's all multiplication. What we've done is we have regrouped and we've moved the parentheses. So this is the associative property. Or of multiplication, or the multiplicative associative property. For D, we have a 14 plus A plus 16 is equal to A plus 14 plus 16. And if you look at this, it is addition, and we are changing the order of the terms. This is an example of the additive or commutative property for addition. And E, 7 times 1 is equal to 7 is equal to 1 times 7. This is the identity property for multiplication. Number 2, give reasons for each of the following steps in the chart on the left. Use the given reasons on the right and enter the appropriate reasons for each step. Well, speaking through the first line of 55 plus 42 is equal to, in parentheses, or the quantity 5 times 10 plus 5, which notice that equals 55, plus 4 times 10 plus 2, which is equal to 42. And if I look at the questions, or the opportunities, the options on the right, the first one is place value. And how we know that is we are multiplying, splitting up the number, multiplying the tens place in each one by a 10. In number 2, what we have done, and it all, we're really adding all of those terms from 1 after we looked at place value, and then we have regrouped, or we've changed the order. And since we are changing the order of addition, we would say that this would be the commutative property for addition, or C. Now what we have done in the third step is notice that we have taken out the 10 from the first set of parentheses, 5 times 10 plus 4 times 10. And that is the distributive property, H, multiplication over addition. We've pulled out that 10. The next line, 9 times 10 plus 7. Now, look at, because I didn't fully look at my options, is this would be in G, single digit addition facts. And then finally, when we look at what we have, I would put here as F the place value. Number 4. My apologies, I need to get rid of that E. I'm going to see if there's actually white ink here, and there is. So I'm just going to erase that E. All right. Now, we're going to perform the operations of 24 base 5 plus 33 base 5. So when I look at this, what I want to do is I'm going to stack it. There are different ways that we can do this, and the way that I'm going to show you here is using, let's practice with lattice. Lattice is pretty nice to use for these types of numbers, because I know that if I have 4 plus 3 base 5, I am going to end up with a 12, and you can use your number line to get that 4 plus 3 base 12. Remember here we'd have that 0, 1, 2, 3, 4, 10, right, 11, 12. And if I started with a 4 and then I added 3, I end up with 12 base 5. All right, now if I go to 2 plus 3, okay, well I can change ink colors here. And I'll use the same number line, and I go 2 plus 3. Okay, then I get 10 base 5. All right, now doing my lattice, right, now we go along the diagonals. I get 112 base 5. So my answer is 112 base 5. Now we can do things even a little differently maybe. When we get 101 minus base 5 minus 11 base 5. The first one is straightforward, right? 1 minus 1 is 0. It's going to be a base 5. That's great. And then we look at this 10 minus 1. All right, so now I'm going to use a number line again. It's just such a great example of using a number line. But in base 2, it'd go 1, 10, 11, 100. So when we look at this, I'm going to start with a 10 right here. But then it says to subtract 1 on the left direction. So I end up with a 1. So my answer is 10 base 5. Moving on to number 5. All right, so the same thing that we're doing with regrouping, we can put in experiences where we are much more used to working with just real life examples. And that's a wonderful one is with seconds, minutes, and hours on our clock. Pretty familiar with that. So the first thing that we can do is we have 41 seconds plus 35 seconds, and that gives us a total of 76 seconds. Now, we're going to want to regroup this, but for now, we'll just look at the 76 seconds. For minutes, we have 35 minutes plus 43 minutes gives us 78 minutes. Again, we will regroup, but let's go ahead and look at hours. And for hours, we have 9 hours. Okay, now we don't talk like this. We don't say 78 minutes and 76 seconds. What we're going to do is we're going to regroup. So I would cancel off of this 16 or 60, and I'm going to get 60 seconds. I'm going to carry this, and I end up with 78 plus 1 of 79 minutes. I'm going to take 60 off of that, and I'm going to have 19 minutes. And then I'm going to move the 1 over to the hours, and I have 10 hours, 19 minutes, and 16 seconds. Going on to number 6. Place parentheses if needed to make the following equations true. So I'm going to look at A. And with A, I have 4 plus 3 times 3. Now, if we were to use the order of operations the way that we're supposed to, we would do the 3 times 3, and that'd be 9 plus 4, and that would give us 13, which is not equal to 21 that we need. But I do see that if I put parentheses around the 4 plus 3, that would give me a 7, and then multiply it by 3. So 7 times 3 is 21. Let's move on to B. So I look at this as 9 divided by 3 plus 1, it equals 4. Now following our order of operations, I would do the division first. 9 divided by 3 is 3, plus 1 is 4. So no parentheses are needed. because the order of operations works well for what we need. C. 5 plus 4 plus 9 divided by 6 is equal to 3. If I use order of operations, 9 divided by 6 would be 3 halves, and plus 9 would give us 12 and a half. That's not what we need. So when I look at this, and I do the addition first, 5 plus 4 plus 9, I get 18. And 18 divided by 6 is 3, so I'm going to put my parentheses around the addition so that we do that before the division. And then D. 5 plus 6 divided by 2 plus 3 is equal to 11. Now, if I did our order of operations, I would take care of the 6 divided by 2 first, and that would be a 3. So 5 plus 3 is 11. So I would say here that there are no parentheses are needed.